Welcome to Basic Mathematical Notations and Definitions for Computer Science students in first semester. Today we're going to be discussing the following subjects. You can go ahead and skip to the time of any of them if you do not want to listen to the rest. Okay, so first up we're going to take a look at the element operator. The definition for the element operator is, in mathematics, an element or member of a set is any of the distinct objects that make up that set. What this means is, when I say that x is an element in y, or for short x and y, that means that, for instance, if you have a collection named y, the collection has the elements 1, 2, 3, 4 until 8. If I say that x is an element in y, then x can be a 1, a 2, a 3, and so on. Now we're going to be talking about the real numbers. The real numbers definition is numbers that can represent a distance along a line. They can be positive, negative, or zero. That basically means that all numbers are real numbers from minus infinity to plus infinity, including but not limited to everything dot an infinite amount of nines. Now we're going to be taking a look at the natural numbers. The definition for the natural numbers is the counting numbers 1, 2, 3 until plus infinity are commonly called natural numbers. However, other definitions include zero. Definitions that include the zero will normally have the include symbol and then a zero within two curly brackets. Now we're going to talk about the integers. The definition is more than clear. They are the positive and negative counting numbers as well as zero. Now we're going to talk about the existential quantification operator. The definition is, in predicate logic, an existential quantification is a type of quantifier, a logical constant, which is represented as there exists. In other words, when we write down that there exists an x in y, then we are saying that there is an element in y that fulfills a certain statement. So if we say that there exists an x in y, so that x divided by 3 equals 1, that means that there is an element in the collection or set y that when divided by 3 will give the result 1. Next up, we're going to talk about universal quantification. The definition for this is, in predicate logic, a universal quantification is a type of quantifier or logical constant which is interpreted as given any or for all. We're only going to be looking at the for all. When we write for all x and y, we say that for all elements in y, a certain property is fulfilled, for instance. We can also say that for all x and y, a certain property is not fulfilled. When we say for all x and y, when x divided by 3 equals 1, we are saying that for all elements in y, when they are divided by 3, they equal 1. Lastly, we're going to talk about the uniqueness quantification, which is there exists only one. The definition for this is, in mathematics and logic, the phrase there exists one and only one is used to indicate that exactly one object with a certain property exists. This is pretty much self-explanatory. So when we say there exists only one x and y that fulfills a certain property, that means that in the set or collection y, there is only one element that fulfills a certain property. So if we say that in y there exists only one x, which when divided by 3 equals 1, that means that in the collection y there is only one element that when divided by 3 will equal to 1. That's pretty much it for today. I hope you learned something, and we will see you in the next video. Happy